Are you struggling with cubic equations? Today I'm going to show you Ruffini's method, an amazing technique that makes solving cubic equations incredibly simple. This powerful method will transform how you approach polynomial equations. By the end of this video, you'll solve any cubic equation in minutes. It's not ours. First, let's understand what we're dealing with. A cubic equation has the general form a x cubed plus bx squared plus cx plus d equals 0. The key feature is that the highest power of x is 3, which is why we call it cubic. These equations can look intimidating, but with Ruffini's method, they become surprisingly manageable. Let's solve this specific example. X cubed minus 6x squared plus 11x minus 6 equals 0. Don't worry if this looks complicated. We'll break it down step by step. You'll see how elegant this method really is. The first step in Ruffini's method is identifying our coefficients. It's looking at our equation x cubed minus 6x squared plus 11x minus 6. We have a equals 1, b equals negative 6, c equals 11, and d equals negative 6. These coefficients are crucial for our Ruffini table. I'll make sure you identify them correctly. Now we need to find possible rational roots using the rational root theorem. This theorem states that any rational root must be of the form plus or minus factors of d divided by factors of a. For our equation, the factors of negative 6 are plus or minus 1, 2, 3, and 6, the factors of 1 are just plus or minus 1. Therefore, our possible rational roots are plus or minus 1, 2, 3, and 6. This narrows down our search significantly. Here's where Ruffini's method shines. Instead of substituting each possible route into the original equation, we use synthetic division. Let's test x equals 1 first. We set up a table with a vertical line and horizontal line. On the left side of the vertical line, we write our test, root 1. On the top row, we write our coefficients, 1, negative 6, 11, and negative 6. Now for the magical part. Step 1. Bring down the first coefficient. You simply copy the 1 to the bottom row. Step 2. Multiply this result by our test root. 1 times 1 equals 1. Add this to the next coefficient. Negative 6 plus 1 equals negative 5. Write negative 5 in the bottom row. Step 3. Repeat the process. Multiply negative 5 by 1 to get negative 5. Add to the next coefficient. 11 plus negative 5 equals 6. Finally, multiply 6 by 1 to get 6, then add negative 6 plus 6 equals 0. The last number in our bottom row is the remainder. Since we got 0, this means x equals 1 is indeed a root of our cubic equation. The other numbers in the bottom row, 1, negative 5, and 6, give us the coefficients of the quotient polynomial x squared minus 5x plus 6. Our original cubic equation now factors as x cubed minus 6x squared plus 11x minus 6 equals parentheses x minus 1 times parentheses x squared minus 5x plus 6. To find all roots, we need to factor the quadratic x squared minus 5x plus 6 factors as parentheses x minus 2 times parentheses x minus 3. Therefore, our complete factorization is parentheses x minus 1 times parentheses x minus 2 times parentheses x minus 3, setting each factor equal to 0. Gives us our three solutions, x equals 1, x equals 2, and x equals 3. We can verify these by substituting back into the original equation. Each one makes the equation equals 0. Now it's your turn. Try solving x cubed minus 7, x squared plus 14x minus 8 equals 0 using Ruffini's method. Hint: test the values 1, 2, 4, and 8. Can you find all three roots? Comment your solution below. I read every comment and love seeing your work. If this method helped you understand cubic equations better, smash that like button. Subscribe to MathFair for more incredible math tricks and techniques that make complex topics simple. Ring the notification bell so you never miss our latest videos. Remember, mathematics doesn't have to be difficult when you have the right tools and methods. Keep practicing, keep learning, and I'll see you in the next video.